We'll do something now that will soothe us all. We're going to analyze my son's 2-year checkup. Now, he just turned 6. But the data I got from this checkup is some of my favorite data that I've ever seen. And the interpretation of the data and what I consider to be some of the misinterpretations of this data are some of my favorite things I've ever heard. So we're going to start with this today. So he just turned 6. Like I said, this was 2/3 of his life ago. Max Benjamin. Went to the doctor, 2 years. I wasn't there for this. I got this from my wife. Here were the 3 measurements I was given that night when they came up with the doctor. He was in the 80th percentile for weight. He was in the 90th percentile for length. And my favorite head girth, 85th percentile. So, for a while I asked students to, based on those 2 numbers, draw my son. They drew him Charlie Brown. It's quite cute, quite cute. And he's got a dome. He's got a dome. If you've ever been to my office, I just printed the most recent one out. I've got a picture of every 6 months in jeans and a white t-shirt in front of my front door. And just watching him change from 0 to 6 has been phenomenal. I mean, he starts with a little protoplasmic bulb that just kind of rolls around. And now he's, 48 inches tall, beating on bike races sometimes. So it's pretty cool. But here's the deal. Here's the deal. This was given to me. How much does my son weigh? You don't know, do you? No. Nor do I. 60 pounds. My wife is a saint. So the question is, how much does he weigh? This doesn't tell you that. But it tells you something. And what I want to have today kind of walk us through is the answer to Max's question. What does it even mean that he's in the 80th percentile for weight, 90th for length, and 85th for head girth? Anybody have a clue? Please, Michael.
On the average of how many children are born, he's closer to 100 percentile would be everybody.
We'll come back to that. Love it. Go ahead. Go ahead.
So he's closest to the average. The higher the number, the more occurring it is.
Okay. Okay. The higher the number, the more free. So it's basically like a weighted average if you would think about it. Okay. I like that. I like that. Please tell me your name one more time.
Jamie.
Jamie, thank you.
I thought that 50th percentile was average.
Okay.
That.
Okay. Got a nod over here. Okay. Let's come back to that as well. That's okay. Thank you. Thank you. This is good. 2 different interpretations. How many of you guys have taken your kid to the doctor and been told they're in the 105th percentile or something? Or yeah, right? Exactly. That's some more. I want to talk about that today too. So here's the thing. This is a term. How many of you guys are nursing students? Nursing students? You guys have to get used to these because this is how they grade you on your TEAS exam. Your TEAS score is based, if you have to fit into a certain percentile in order to get accepted to the program. You're all going to kick ass, don't worry. I'm going to scare you off. But here's the thing, now we've heard a couple different interpretations, and then plus the TEAS thing. So what exactly is a percent? Okay, so here is how to answer that question. It's a long-winded answer, because it's me, and because I'm kind of the opinion we should drag every bit of meaning out of everything. So you'll get used to that. I'll have this posted for you after class. I'll post the PowerPoint so you'll have all this data. What I did right here was I randomly selected 100, actually I randomly selected 99 white 2-year-old American males. Max is also in there. Where is he? Sorry, no 60-pounders. Harrison, no 60-pounder kids. Not a 2 anyway. So find Max.
I thought it was a 6.
What's that? Oh, that's 6. Gotcha. What's he weighing now? I think it's 45 now, 46, something like that. He's a string bean. And so watching him change has been, as soon as they start walking, all the protoplasm becomes muscle and hair in this case. I don't know where he gets that from. Where is he?
Actually, he's one of the 30s.
He's one of the 30s, 27? Is that what I heard? 27, one of the 30s. You guys agree with 30 to 27? 27s, Robert?
Yeah, I'd say
27. So we got a bunch of 20s, maybe a low 30. Okay, good. This is raw data. Could I ask you to find the average of this?
Yeah.
Yes, I could. I will not. If I ever wanted you to find the average of this block of data, I would use that text to columns trick in Excel, select the whole thing, drop it in Excel, and do it that way. But I won't ask you to do that right now. Instead, we're going to agree that it's hard to find Max in there. He's in there. It's hard to find him. Okay. How about now? Now, let me ask you a question. Did I make it any easier to find Max?
No.
Well, good. Either yes or no is a correct answer. No, I didn't, because you still don't know what the hell a percentile is. But yes, I did, because once you know what a percentile is, it'll be really easy to find and use this. So let's go through that one by one. First of all, describe that data to me. Describe that data to me. And Jamie, I'm going to answer your question first. We'll get back to Michael in a second. I'll get to you first. Describe that data to me. And don't be calculating PSSE. Just give me, not the,
Slightly better.
slightly good. Bell-ish, but it's definitely got some skew because of these kids over here, yeah? So we can decide, and if you call that bell curve, call a bell curve and operate as such. If you call that skew, call it skew and operate as such. There's not going to be a correct answer. It's how you look at that. It definitely has bell-shaped characteristics. I only drew 100 kids. There might be a lot heavier kids. Now here's the trick though, and we'll be able to answer this question soon enough because I have a pediatrician's growth chart tagged on at the end of this. There might be heavier kids than 33 pounds. But if 33, this goes back to what Michael was saying, if that's the heaviest kid out there, that means the distribution stops right here. Which means we really don't have a bell curve, do we? We've got a blob here and then it tails off over here. But that's assuming that 33 is the heaviest weight for a 2-year-old kid. It could be 40 or 41 or 42 pounds, and I just underrepresented it in this particular data set. So call it anything you want to, whether it's skewed or whether it's bell. There's not going to be a correct answer on that. As long as you do whatever you do after you decided that correctly. That's all I care about. Good? All right, so where's the average? Where's the average? Regardless of whether you call it a bell shape or not. Patrick?
30.
He's calling it 30. He's going to say it's over here. Why so far to the right, friend?
Just looks like where most of the data is.
Oh, good. So you're going with mode. Actually, yeah, mode is definitely 30. Hands down.
Closer to 27 to
Yeah.
outweigh 28.
For a balance point, maybe 28 or
Remember, means a balance point. It's the shared, fair share. But it's also the balance point. It's where you have to put your finger to balance this. If this was like a tray with different sized bottles on it, you're the waiter, and you're going to put your hand in the middle to kind of balance that. Okay, 30 might be a smidge too far to the right. I think 27 is a smidge too far to the left. I'm thinking it's somewhere in here. You have to balance that tail that's out there. So you're going to have to move a little bit towards that to balance that tail, but not so much to lose all this stuff over here. So good, we're somewhere in here. The mode's definitely 30. Go ahead.
Sorry,
Go ahead,
not to
Patrick.
interrupt you.
No.
When I see a chart like that, and the top comment says weights of 100 randomly 2-year-old, you know, I would have handed it back to the accountant and said, well, what does the 16 mean? Where's the 100? Because it says number of boys on the, what is it, the y-axis?
The y-axis, yeah.
As a
Right.
frequency.
It's frequency. There are 16 boys that are 30 pounds. 15 that are 29. 13. You should still hand it back and be like, dude, interpret.
Well, yeah, because I don't know where, I'm not sure that I know where the 100 is.
When you say the 100, oh, add them all
Add
up.
them all up.
Yeah,
That's the idea.
everyone, the good question, every one of those weights is in this chart. 3 of them.
Based on, I get it. I'm sorry.
Right, don't be sorry, don't be sorry. It's always good for clarification, because otherwise the next 20 minutes won't make any sense to you. So yeah, to make sure. And what I often do, I didn't do it here, but I do it a lot of times in the dynamic ones I do in class. I'll put the numbers on top of the bars, and then just take the scale away. So that way you know 16, 15, 12, 3. And just sum them all up and flip to 100. Thank you. Good? Make sense? Okay, good. You're diligently entering, Jim. Please, just process this right now, my friend, please. I know it's so tempting. But just process, okay? Where would the median be? JC, get up here. I'm kidding. We're not going to do that anymore. Where would start chopping, right? Start chopping to find the actual median. Where do you think the median is, friends?
28.
Yeah, I'm guessing it's somewhere around here. If you lop off these bars, I'm thinking these bars are pretty much going to lop off everything up to about here. Yeah? And then this and this together probably lops this off, and somewhere in here is your median. We could always crunch the numbers for more precision, but ballpark it. So check this out. We said the average and the median are ish coming pretty close to each other. I'm guessing the average is a smidge lower, but the mode's higher. So we're starting to see that kind of indication of skewness a little bit because they're moving away from each other. This goes to what Jamie said when you said you thought the 50 percentile was the average. Sometimes it is, sometimes it's not. More on that to come. Thank you for that. That was perfect. Sometimes it is, sometimes it's not. It depends on the shape of the data. We'll come back to that, okay? All right. Max was the 80th percentile for weight. We still haven't found him yet, have we? Okay, here we go. Let's start. How many 2-year-olds in this chart are less than 26 pounds in weight? And strictly less. Strictly less. Not equal to, but less. Go ahead. Have at it.
20?
You get 20? 20?
24.
24? 22? Okay, let's count. 3, 4, 5, 6, 7, 8, 12, 20, that's it, 20. 20, right? So 20 of the 100, or 20%, are less than 26 pounds. Cool? Keep that in the back of your mind. That's called a quintile. We'll come back to that. We'll come back to that. We'll come back to that. Don't you worry about it right now. It's called a quintile. We'll come back to it, I promise. Do it one more time. How many are less than 29 pounds? Not equal to, just less than. I got 49 as well. 49? I'm going to double check. 20 is to here, right? Plus 9 more is 29. 7 is 36. Plus 13, it should be 49, yeah? So that's just about half of them. Which means I think we just found the median. Didn't we? We just did. We found the median, because if it's less than 29 pounds, 49 comes to here, that means 50 and 51 are right in here. So it's essentially 29, but it's almost 28. So we were correct in saying it's right around in here. Damn straight, it's right about there. We just found the 50th percentile. The median is always the 50th percentile, but it's not necessarily the average. 50th percentile is always the median, because it's halfway through. It's halfway through when you order them. Halfway through. Okay, we'll come back to that. We're going to formalize all this as we go through today. But just so you know, so this is Jamie, your point was well taken. If the average and the median are the same value, then yes, 50th percentile is definitely the average. But it's always the median by definition. Cool? And the more skew the data has, the less likely it's equal to 50th percentile, because the average keeps tampering away. Cool? Thank you, sister. Okay, you ready? You ready to find Max? He's like,
I mean,
80% of the sample. 80% of the sample is less than 31 pounds. So I was able to figure out, oh, Max must weigh 31 pounds because he's heavier than 80% of white American 2-year-old boys. Granted, this is just a sample of 100, but I have a bigger sample I can show you here in a minute. I've got millions of boys represented in the chart, which I'll show you in a minute. This is just a representative sample from that. Go, Harrison.
So if it's like 105th percentile.
Hold that thought. Just hold that thought, brother. Hold that thought. We'll come back to that. We're not ready for that quite yet, because we're still make a piece with this. I want to make sure you understand what a percentile is. Max is 31 pounds, because 31 pounds is heavier than 80%. That is the most common definition of what a percentile rank is. It's a simple percentage, and it's the percentage of data you exceed. That is the simplest way to interpret a percentile. It is by no means the only one that is used. But they all mean essentially the same thing. There are various differences in the formulas of percentile ranks that are sometimes used. I'll have you guys analyze them on the next data class exam. I put together a really nice Excel spreadsheet that kind of analyzes that. But what you'll learn is it doesn't matter which one you use, they all simplify down to this. If you're in the 80th percentile, in some measurement, it means you are higher than 80% of those on that measurement. Max was in the 90th percentile for length. That means he was longer than 90% of white 2-year-old American boys. 85th percentile for head girth means he was head girthier than 85% of white American 2-year-old boys. Right? Go.
I'm sorry, why is that important?
Why is it important? Well, let me tell you the rest of the story,
Okay.
if you don't mind. So, my wife comes back from this, and she's furious. I'm like, okay, what's up, babe? Make dinner, you tell me. And she goes, well, here's his test results. I'm like, okay, here they are, 80, 99, 85. And she said when the practitioner looked at the numbers, they asked Jen, he's in the 80th percentile for weight. What do you feed him? And Jen said, food. And practitioner goes, yes, what kind of food? And Jen's like, well, he loves broccoli, he loves apples, he loves cheese quesadilla. She's like, oh, cheese quesadilla. How often does he eat cheese? And Jen's like, What the hell do you want to know? And then the statement was made, any child over the 50th percentile, they asked the parents about overfeeding and obesity rates. Any child under the 50th percentile, they question about malnutrition. And I started getting, and Jen goes, so I told her, so basically you ask every single parent and you accuse every single parent of either overfeeding or underfeeding their child. And the practitioner got all freaked out, well, and Jen's like, because essentially, anybody over 50th percentile is the top half of the data, and anybody under 50 is the bottom half of the data, so you're asking everybody. Now, Jen backed off at that point. I'm so proud of her. I'm so proud of her. Well, yes, of course! You're implying my child's obese. So, what happened? They ignored the other two measurements. Sure, he's in the 80th percentile for weight. Guess what else? He's in the 90th for length. If he was in the 80th for weight and the 10th for, if the 80th for weight and the 10th for length, I'd be like, okay, he's this big and he's this wide. Let's talk about getting rid of some of that fat. But look at his numbers: 85th percentile, 90th percentile, 80th percentile. He's just a big 2-year-old. Guess what he is now? Roughly in the 60s. Because his body grew into his head, I guess. I don't know. Whatever the hell happens to him today. There's a lot of variance. You'll see why momentarily. So Robert, it's important to keep track of that stuff, just to kind of track growth over time to see what happens. But it's also important to know how not to use the data.
Right.
You see what I'm getting at?
Yeah.
Fair?
Yeah.
Now,
Yeah, math can be evil. Yeah.
well, the misinterpretation of math, be careful.
Oh yeah.
Math is pure. Statistics is pure, but the interpretation of that can be disastrous.
Oh gosh.
Oh yeah. So here, back to 105th percentile. Harrison, you asked about that. In my opinion, that's meaningless.
Because it's just over the sample.
Because it implies that you are actually bigger than more than all of the data. Does that make sense?
So basically it's just like the sample. If they went from like, A to B, you're just a little bit past outside of their sample.
And this, thank you for that. This brings up another interesting point. I'm going to come over here to answer this, because this is, I've been told a number of times my child's in the 105th percentile and the 107th percentile. Here's my problem with that, okay? The assumption with that, and you just described it perfectly, by the
It's
way.
like BMI.
Oh, don't get me started on BMI.
I know, it
Don't get me started on
is.
BMI.
Wrestling.
Don't get me started on that crap. The problem I have with the 105th percentile, not the BMI, let that go, is the assumption of that is that here's 2-year-olds. And here's 3-year-olds. And I don't care what we're measuring, whether it's head girth or whether it's length or whether it's height, whatever. If you're telling me that somebody's in the 105th percentile, you're saying that your child, it's max. Suppose he was in the 105th percentile for head girth. That means his head girth exceeds all of that of 2-year-olds and 5 of 3-year-olds. That's absolute garbage, because the curves don't look like that. You're implying that the head girthiest 2-year-old is still bigger than the smallest head girthy 3-year-old. That's ridiculous. These curves look more like this. On average, 3-year-olds are bigger than 2-year-olds, but that doesn't mean you can't have a 3-year-old that's smaller than a 2-year-old. So what the hell does 105th percentile mean? It means nothing. I have yet to see anybody interpret that correctly, because you can't. By the definition of percentile, you can't exceed more than there is, right? You're not as pissed off as I am, it's okay. You will be. Because when you see these things misinterpreted, it is patently absurd to see that the 105th percentile has no meaning. There is no biggest kid.
Yeah.
There is.
That's a new ending.
No, but there's not, because that kid just changed. That kid just changed. You see what I'm saying? It's a constant flux. Yes, okay, Kate, there is a biggest kid. Yes, he's out here somewhere. But he's changing too. As we're sitting here talking about this 2-year-old, he's changing.
You have to constantly change the percentile.
Yes, but that's not worth
Every
doing.
single-
Right, every single
It's an
moment.
average.
It's JC, thank you. It's an average. This curve, I've been told, and historically you can see this curve is moving to the right slowly over time. As our diet gets better, as our lifespans get longer, we're getting bigger, we're staying healthier, on average. We can't chase the outliers to force the curve to go away. Now, there is a couple things you have to think about. Let's back up to our data again real quickly. Real quickly now. Whoops, keep the stand up too. Let's talk about these small kids. I know we can't talk about the small kids in the entire population because they're constantly in flux. Let's talk about the sample, friends. What percentile percentile is he? Our little 20-pound friend. He's adorable, isn't he? He's tiny and cute. What percentile is he technically?
Like 10?
Like 5.
Technically, by the definition of that percentile formula, what is he? He's the 0th percentile because what doesn't he do? He doesn't exceed anybody. He's the smallest. The definition of percentile is the percent of those you exceed. So he would be the 0th percentile, wouldn't he?
So by definition, there could be a negative percentile too,
Well, how would that be?
if you were less than 20 pounds.
Oh, but then this 20-pounder would be the 0th percentile anymore.
Right, but if it's
Hang on, just in this sample right now. Keep it simple, just in this sample. Suppose this is the smallest kid, and for the sample he is. If there were a 19-pounder down here, he's the 0th percentile, and these guys are slightly larger, whatever the percent is. Is that fair? They'd be the 1st percentile, wouldn't they? Roughly, because they're bigger than 1% of the data-ish. A little bit smaller, but 1%. You see what's going on? As you throw data points in, the relation between the points is changing. That's important. Keep that in the back of your head for right now, too. Thank you, Michael. Very good point. Very good point. And this implies that somewhere there is a smallest kid, which is hard to process because y'all figure the news, oh my God, a 7-pound kid was born, or 7-pound triplets were born, or something like that. Each one weighed 1.5 pounds. Like, holy crap, how'd they stay alive? Well, because medicine keeps them alive. So this is constantly in flux. But don't get too hung up on that. Just realize he would definitely be the 0th percentile. Who would this kid over here be? Can he be the 100th?
No.
Because he can't exceed himself, can he?
Like 99.
So he would be the 99th percentile in this data set. There are 100 data points in there. That kid's bigger than 99 of them. He'd be the 99th percentile. How many of you guys have ever taken like a standardized test that when the results come back as a percentile, anybody ever get the 100th percentile or anything? You can't. You can get the 99.99999, even if you're the highest score on everybody takes a test. You can't beat yourself, right? You can't do better than yourself. You can do better than everybody else, but you can't do better than yourself. Now there are other formulas that don't allow for 0th percentiles, and we'll deal with those later in time. I don't want you to worry about that right now. Right now, just think about percentile as being the chunk of data you're bigger than. And whatever you're measuring, whether it's height, whether it's T-scores, whatever you're measuring, it's the percent you're higher than. Keep that in the back of your mind, everything else is great. Make sense so far? Now, getting percentiles, remember how I asked you about 20 minutes ago, I was like, would this be easier to help us find Max's weight? And you were kind of like, no. And then some of you were like, well, yeah. You were both right. No, because you didn't know what a percentile was, but yeah, now that you know what a percentile is, isn't this easier to find than this? Right there?
Yeah.
I mean, you could do it this way too, but you'd first have to sort all the data and figure out where the cutoff was, and then you don't want to do that. Well, as it turns out, this isn't the most efficient way of identifying percentiles. This is a much more efficient way. Check that out. And Patrick, this goes back to your question. This is what you wanted from the very outset. You wanted this, but I didn't want to hit you with 2 new things at once. One new thing at a time is enough, I think. Thank you. This is what's called a cumulative frequency histogram. You see what's representing now? Patrick said he wants to see the 100. Well, there it is now, up on the left there. But look at the vertical axis. Number of boys at or below that weight. So check this out. Check this out. There's your 20-pound kids. How many of them were there again? Do you remember? I think there were 3 of them, right? There was a little spike at the end there. Well, there's still 3 there. Now remember how many 21-pound kids there were? I think there was just 1. I think there was just 1 of them, I think. Look how this bar is now at 4. Right? Why is it at 4? Because 4 kids are 21 pounds or less. So there's the 21 and the 20-pounders. There are 4 of them altogether. Cumulative! That's where the cumulative comes from, Robert. That's why it's cumulative, because, and like I said, you guys are going to have this PowerPoint. You'll have all this stuff ready to go for you.
How much did you say Max weighed?
31 pounds! So if you go over to 30, 80, which means he's got to be 31 or higher, but they wouldn't go higher, because if he was 32 pounds, they would have said that Max was the 92nd percentile or something like that. So when they say he's in the 80th percentile, what they've told me is 80% of boys are 30 pounds or less. Max is 31, because he kicked that. is 1 plopped over from that. Kate, you don't look satisfied with that answer?
No.
Oh, is that okay? Just processing. Good for you, sister.
That 1 pound makes a big difference.
It makes a humongous difference, and it's all based off an eyeball. Come back to that in a second, Michael, if you don't mind. 1 pound makes a humongous difference, especially when they're young like this. You're about to see why. It makes a far less difference at our age, obviously, but when they're young, and you'll see why, it's a humongous difference, and sometimes it's a data interpretation error that leads to horrible testing that doesn't need to be done. Come back to that in a second. Very oftentimes, this histogram is a little bit overblown, a lot of ink on the paper. So sometimes what they'll do is they'll just take, they'll create this, which the formal mathematical name is a cumulative frequency line polygon or something like that. But there's a great little word called an ogive. It's one of those things like, it's like calling it Ralph. I don't know where this word came from, but it's the only one. Like you have histograms, frequency histograms, distributions, frequency distributions, and then you got Ralph. Like, I don't know where ogive comes from, but do you see how it's showing you the exact same thing?
Yeah.
It just takes the bars away. Here's the one doctors use. That's their ogive. Some of you have seen this before. I've seen some nods. Yes, some of you may have seen these before. So, let's find max. Now, the way max was found, we did it backwards. I showed you his percentile and asked you how much he weighed. When the doctors do it, they weigh the kid first, and then they give you his percentile. So they would have weighed max and said, okay, he's 31 pounds. So what your job is to do is to find him. Here's birth to 3 years, 36 months. So he was a 24. He's a 24. They weighed him, he was 31 pounds. So you find 31 pounds, 16 weight pounds, 31 right here. Okay, you go up, and you come across. There's max right there. Can you see the percentile lines coming across? Your median, 50th percentile, looks like it's right above 28 pounds, maybe 28 and a half pounds, they're calling median. That's damn close to our sample, wasn't it? 28 and a half pounds. Okay, there's 75, the 75th percentile. What would you have to weigh there? It looks like exactly 30 pounds. If you were a 30 pounder, you'd exceed 75% of the data. There's max. Here's the 90th percentile. I believe the 95th percentile is where the cutoff for obesity is. I have huge issues with that. I have huge issues with cutting off 95th percentile obesity. Why?
Was there really
BMI.
What if the kid's really tall? What if he's in the 100? What if he's in the 99.99th percentile for height? Michael?
They're just super young. What if he had a huge meal right before it too?
Oh my God, the one, dude! I didn't think about that. You could. I've seen Max eat about half a pound of food,
Yeah.
and then pass out like pass the hell out of the way back. Food coma. Food coma. So you see where his 80% is? Go, Hattie.
Or the kid hasn't had a bowel movement in 4 days.
Oh, exactly. Like the anti-food. Exactly. I mean, look. As they get, look how close the 95th to 5th percentile is at birth. It's less than 2 pounds apart, it looks like. Right? So if you're off by a couple grams, you're talking about a 10 or 20 percentile point difference. And it doesn't widen, I mean, it widens a lot more to this, but look at the difference. Between 95th, it's about 31 pounds, 32 pounds, down to 26 and a half pounds. That's 6 pounds different at age 2. If you're off by a pound, you're talking about a size, it's just like Michael said, you're talking about a sizable difference in percentile. And decisions are made based on percentiles, sometimes bad ones. So it's important to measure that. There are much more precise ways to measure percentiles rather than pulling off charts. We'll learn as we go through the course, as we get to the bell curve in particular. Okay? That's enough for today. We'll talk more about why we care about this next time, because we do care about this an awful lot. Okay, next time exam first, we'll get back into this after. Sir, yes? You did, Andrew. I emailed you back today, so I asked you, my last email was, when can you make it?
Yeah,
Oh, you did? I didn't see that yet. Perfect. Come in, yes, Grandview, that room over there, 114, I'm going to get, that's 105, just come by, we'll have a take it in. Perfect. Absolutely, you got it, brother.
They are, right.
Harrison! You're doing 13 victories now? Yeah, you are within great. Yes, and that's what you have to process right there. I don't, that I can't do it in my head. I trust you. But you've got an interval resting down the right. Yes, okay, sweet. Good man, good man. higher?
Did I miss?
I don't know, let's see.
Just love, I didn't go. Yeah. First one.
With excessive debt
Oh, okay.
is more likely
Has anyone ever told you that you look like you're at Clapton?
than a college grad.
Recently, somebody did.
Let's become back at it. I'll put all that on.
I thought of you.
Office hours are perfect.
Just
If you have time tomorrow,
Were you watching
do you get that tomorrow?
Well,
Okay,
it was a
I'll be there
West
for
Wing, it was
12:30.
because of West Wing.
And we'll chit chat then? Cool. Andrew, let's take a look. So I just read this one.
College grad with excessive debt in their financial excessive debt in their
So it became a subplot of the show. Where the hell
Without
is that?
excessive
It was like the one he always gave a speech in. So he
Getting married.
last part of the program. So he gets the time. He's getting ready to walk out on the stage.
It has to be the college graduate lady's getting married in both, but I don't know why you would write that without putting the ladies. So she's a little harsh. Let's do +2.
Sean, are you gonna give that to me next time?
You forgot one word. You forgot and the one word does make a
It is
huge
the
difference.
greatest program.
Because it's not that the college graduates is getting married, it's that they're delaying.
Because look, Martin Sheen gives.
They both have to be, because that's what
What have you done?
is more likely to delay getting married.
Josh has to take
Is likely to delay getting married. So it's, both of them are delaying getting married. It's that one is more likely
Isn't
than
that a
one with
great
excessive debt.
metaphor?
Everything else is
So
perfect. Everything is just
sick
right.
for many years, and it's one of those things where you get your boss.
No, okay, this, you're damn close, no, you're damn close on this. You said for every 3 times out of 10 sicknesses, the child will get sick. Well, you have to be careful with the interpretation. First of all, we're talking about the
I got my
magnets.
glasses, I got my.
So they won't get seasonal adjuncts. And I love the 3 out of times, the 3 out of 10
And the
times.
way she
What
looked.
you're implying right there is, if we sample lots and lots and lots
That was
of
like her best character. in my
where the
opinion.
adults
Oh.
have,
All the things that she could
both
bring
parents
in,
have
she
seasonal
did such
allergies
a
or
great
eczema.
job.
Yes.
3 in 10 of those times the kids won't. So I think you've got the important thing,
Oh,
which
yes.
is the understanding that it's
Oh,
an
yeah.
overtime average.
Right, that's why
I think what you missed though is, be careful. Number one, it's the complement of this one. These are the ones that
I
are getting
can't
sick.
remember what she, yeah, no.
And secondly, you stated that both parents have to have
She's got a
seasonal
degree in
allergies. Does
sitcoms.
that make sense? So
Yeah.
conceptually, I think you've got to
And
find some code.
remarkably. I mean,
Cool.
you see-
If I keep this till next time, get their voice back. I'll see you tomorrow morning. Thank you for getting back to me, I appreciate it.
Totally.
Beautiful.
Ryan,
Yeah.
how are you? Hey, you still feeling good? Let me turn the camera real quick.
Color Gazelle on West Wing.
Yes.
Yeah, she's